Alright, the question on the table in this algebra lesson has to do with like terms and order of operations. So let's look at the example here. Let's say that you have in parentheses 2 plus 3x, okay, and then you put plus 9. Well, the first thing you should know is that you cannot add 2 and 3x. And the reason is they are not what we call like terms. Okay, a term is something that usually has a letter or variable attached to it. So for instance, 7y, okay, and 8y would be like terms because they both have a y. 4t and 6y would not be like terms because one has a t and one has a y. Okay, so when we're talking about the ability to add or subtract in algebra, in order to add or subtract, the two things that you're adding or subtracting must have like terms. So in this particular problem, because the 2 does not have an x, okay, there's no x, you cannot add them. Now, order of operations says that we have to do what's in parentheses first. Okay, so if we can't do what's in the parentheses because they are not like terms, okay, then we have to kind of start to think, what are they trying to get at here? And the other thing that is at work here is actually called the associative property. Okay, so what the associative property says, and I'll give you an example, is if I had 3 plus 5 plus 7, okay, let's just work with that for a moment, okay, 3 plus 5 plus 7. If I were to put parentheses around the 3 and the 5, that kind of looks like what we're working with up here. All right. Now let's look at the same problem again. Let's do 3 plus 5 plus 7. But instead, this time, let's put the parentheses around the 5 and the 7. Now, order of operations states that whatever is in parentheses must be done first. So in my first example here, okay, I would go ahead and I'd add the 3 and the 5 and get 8. And I'd go plus 7, and that equals 15. Now down here, let's do this. Okay, I'm going to do the 5 plus the 7 first. 5 plus 7 is 12. Okay, so then I go 3 plus 12, and I get 15. So what the associative property, okay, this guy right here, the associative property of addition, what that tells us is that we can move parentheses around, and we still end up with the same answer. Okay, so what I can actually do in this problem is instead of doing the 2 plus 3x, okay, because it's all addition, it doesn't matter what order I do it. So in reality, I can actually take off those parentheses. Okay, so that's what I'm going to go ahead and do here. Now, I'm going to go ahead and let me see if I can get rid of it here. I just want to erase a few things. Okay, actually I'll just rewrite it. So 2 plus 3x plus 9. Okay, now I do have like terms here. The 2 and the 9 are like terms because they both don't have variables. Okay, so 2 plus 9 is 11. I cannot do anything with this 3x, so I'm just going to carry it down. And believe it or not, that is my answer. Okay, so let's kind of recap a few of these ideas. First of all, like terms. Like terms are things like 3 and 7 are like terms. So check. 3x and 9 are not like terms. Okay, so x. And maybe I should just put a big cross right through them. They are not like terms. 7y plus 2y. Okay, if I were to add those two, I could add them because they have like terms. All right, and I can explain this even another way. Imagine for the moment that you have this 3x and 9. Okay, and we're going to add. All right, for the first part you should recognize is 3x is really 3 times x, which really means that you have 3 x's. Okay, if I was like counting x's. So if I had 3/4, it'd be like saying 3 times 25 cents or 75 cents. So really this is x plus x plus x. That's what 3x represents. It represents 1, 2, 3 x's plus 9. Well, I can't add an x and a 9 because they're not the same kind of thing. That's why we say you cannot add things that are not like each other. Okay? However, take a look at this 7y and 2y example. That's like saying I have 7 y's, y plus y plus y plus y. Okay, and you can see that it goes on here. All right, so that's like 7y right there. And I'm going to add 2y. Okay, so y, y. That's 2y. Well, those are all y's, so it's like I'm adding up all of them together. So that would be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 y's. So those are like terms. Therefore, I can add those two things, the 7 y's and the 2 y's. Okay? So really, it kind of depends on what's at the end of your term. All right? Another example here, and this is a little bit more complicated. 6x plus 7y plus 3z. Okay. This is a term. This is a term. And this is a term. And you'll notice that they're all different. This has an x, this has a y, this has a z. So I can't do anything with this problem because they're all different. So if I was asked to write the answer to this problem, it would be 6x plus 7y plus 3z. Okay? Now, if I were to change one of those so that it read 6y plus 7y plus 3z, well, now I have two things that share a variable. And because of that, those two terms, this term and this term, can be added. So 6 plus 7 would be 13. Y, it's like having 13 y's. I take 6 y's. It's like saying I have 6 yaks plus 7 yaks. I have a total of 13 yaks. And I add that 3z at the end. That would be my answer. All right, now, last but not least, sometimes it's going to ask you to justify or simplify the expression or justify it. Remember that when you're working through problems, okay, justifying means that you need to show your work. So I'll give you an example of this. Let's say I had 2 plus 6n, okay, that's an n, plus 3. Okay? If I was to justify, or first of all, they might ask me to simplify my expression. What that means is this is an expression, okay? It's an expression because it's got mathematical terms and because it can be simplified, which means that things can be combined to make it smaller. Okay, so when they ask you to simplify the expression, they're asking you to do whatever you can to kind of consolidate or put things together that are similar. Okay, so the first thing we're going to look for is like terms. Now, what I'm going to do is I'm going to justify this. What I'm going to do is I'm going to say, okay, in order to show my work, to show someone what I'm doing, I've got to do things to show that I'm doing the right stuff. I'm kind of justifying my answer. Okay, so what I will do is I like to use symbols. So I might put a triangle around this 2. If there's anything else that does not have a variable, I can put a triangle around that 2. Okay, so I see the 3 has no letter. So those things are like terms. Now this 6n in the middle, I'm going to circle that. That's different. Okay? So I can add my triangles, but I can't touch the circle because there's nothing else that can go with it. So I add my triangles. That's 2 plus 3, so that's 5. Everything in here is addition, so I'll just put a plus sign. And I carry down what's left, 6n. So what I've done is I've justified my answer by showing my work. Okay? So that's kind of how this works. Alright, if you have any questions, feel free to contact me at mrbornheimer@gmail.com. Thanks for watching.